Hey everybody, Mr. Bucko here with an example from Geometry Section 1.5 where we are determining where two lines intersect on the coordinate plane. We're given two equations, must determine at what point do those two lines intersect. So we are given an example of finding the coordinates of the intersection of the two lines whose equations are 3x minus 4y equals negative 17 and 5x plus 6y equals negative 3. And we're going to find that intersection point by elimination or addition. This is something that you did in algebra last year. So we're going to take these two equations and we're going to manipulate them. We're going to change them because the way that they're set up now, we have a 3x and a 5x. Those don't match up. They're not opposites. They won't cancel out if we add them together. Similarly with the negative 4y and the positive 6y, those will not cancel out if we add them together. So we need to change them so when we add them together that something cancels out, one of those variables. So I'm going to take this top equation and multiply by negative 5. Where does the negative 5 come from? Hopefully that will be clear in a moment. I'm going to take the bottom equation and multiply it by 3. Those numbers aren't picked randomly. I chose them for a reason, and that should be clear when we see what happens when I do that. So if I take the top equation and multiply it by negative 5, I have to multiply everything in the equation by negative 5. So negative 5 times 3x, negative 5 times negative 4y, and negative 5 times negative 17. Doing that multiplication gives you this equation here. Negative 15x comes from the negative 5 times 3x. The positive 20y comes from negative 5 times negative 4y. Negative times a negative is a positive. 5 times 4 is 20. And the 85 comes from negative 5 times negative 17. Negative times negative, positive, 5 times 17, 85. The bottom equation here comes from multiplying 3 by the bottom equation. 3 times 5x, 15x, 3 times 6y, 18y, 3 times negative 3, negative 9. This is our new system. This system here and this system here are exactly the same. This one was just manipulated by multiplying the top equation by negative 5, the bottom equation by 3. Now when we add these together, which sounds a little weird, but we can do it, negative 15x plus 15x is 0. The x's have been eliminated, hence why this can be called elimination. The 20y and the 18y sum to be 38y and 85 plus negative 9. That gives us 76. So this is a very basic algebraic equation now, and we can see that this implies that y equals 2. If 38y equals 76, then y must equal 2. We're not quite done. We know that y is 2. We have to find the x value because we want the coordinates. This is one coordinate. We need the x coordinate now. And once we have one, the rest is fairly simple. So we move on. We take the the bottom equation, just because I think that one is easier. I like that one better. It looks like it's easier to work with. And what I'm going to do is I'm going to take the y that we found, which was 2, and plug it into the y into this equation. And when I do that, we're left with just an x, which x will now be easy to find, or possible to find. So we have 5x plus 12, and this 12 here comes from 6 times 2. Subtract 12 on both sides, we get negative 15. Divide both sides by 5, and we get x equals 3. So as a result of this, these lines intersect at the point negative 3, 2. If we were to plot these on a coordinate plane, these two lines here would intersect at the point negative 3, 2, and we found that using algebra.